Today we're going to be talking about how to find the dot product of two vectors, and in this particular video we're going to be doing two separate problems. In the first problem we have two vectors a and b. The first is the vector a equals 4, 1, 1/4. The second vector is 6, -3, -8, and we need to find the dot product of these two vectors. Remember that the dot product is also called the scalar product or sometimes the inner product, and really all we're doing is multiplying the components of each vector and then adding them all up together. That's kind of why I like the name inner product, even though dot product is the one you should use. Inner product helps you remember that we're multiplying these inner components here, and we notate it when we have a and b like this. We say a times b, and it can't just be written a, b like this. It's not just a multiplied by b like two variables. The dot product is truly notated with this a dot b, a times b, and it has to be written that way so that we know that it's a dot product. So the dot product of a times b is just going to be the x components multiplied together. So 4 and 6, we'll multiply 4 and 6 together. Then we add to that the multiplication of our y components, the product of our y components, 1 times -3. And then we add to that the product of our z components, so 1/4 times -8, like this. So then we just simplify. We can multiply each one. We'll get 24. We'll get 1 times -3, which is -3. And we'll get 1/4 times a -8, which is a -2. 24 minus 3 minus 2 is going to be equal to 19. So the dot product of a times b, where our vectors a and b are defined by these components here, is 19. Now let's take a look at a slightly different example. When we have vectors defined in terms of I, j, and k, remember that the coefficients on these components here, I, j, and k, can be translated into this same form as this first problem that we had here. So if we start with b here first, I is kind of associated with this x coordinate, j with the y coordinate, and k with the z coordinate. So b can really be defined here as the coefficient on I, which is a +1, the coefficient on j, which is a -1, and the coefficient on k, which is a +1. So that's really just b equals, and then this kind of coordinate point here. For a, we can say a is equal to, same thing, 2, 1, because the coefficient is 2 on I, the coefficient is 1 on j. There's no k value, so essentially here we have +0k, which means the coefficient on k is 0. So that's how you can think about it. And then our dot product is the same thing. A times b is equal to 2 times +1 plus 1 times -1 plus 0 times +1, like this. If we simplify, we'll get 2. 1 times -1 is a -1. 0 times 1 is 0. 2 minus 1 plus 0 is just 1. So our dot product of these two vectors, a and b, is just 1.